Hey y'all, let's cover lesson 8, addition and subtraction of integers. Okay, we're going to return to the idea of using number lines to represent addition and subtraction for integers. An important change is the introduction of negative numbers. That's the part of the integers we haven't spoken about much. A positive number is represented on the number line with an arrow pointing to the right. A negative number is represented on a number line by an arrow pointing to the left. Okay, so use a number line to add 3 plus 4. So if we have a number line and let's throw some numbers in here. -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 10's good. All right, so we've got 3. So from 0 to 3 is 3. And then we're going to add 4. We're going to go here. We're going to add 4 more. And that is going to give us 3 plus 4 is 7. Okay. The next one is we're going to use the number line to add -3 plus -4. So I need numbers a little bit further to the left now. Go with not very good at my spacing. I'm so sorry. -7, -6, -5, -4, -3, -2, -1, 0, 1, 2, 3. That's good enough. All right, so we're starting at -3 right here. So 0 to -3 is -3. And then we're going to add another -4. So 1, 2, 3, 4. And that puts us at -7. So -3 plus -4 is -7. Okay. A couple of things I want you to get from this, just from the two I've just done. And I know we haven't really been speaking a lot about signs. These are both positive numbers. +3 and +4 gives us a +7. When the signs are the same, they're both positive, you add them. So the signs are the same, you add. And the answer has the same sign. Answer has the same sign. The same thing goes for down here. The signs are both negative. If the signs are the same, we add them, and the answer has the same sign. That's what just happened. This is your cue. This is what I think about whenever I see this. I say, oh, the signs are the same. I'm going to add them, and I know my answer is going to have the same sign. That's how I view these. Let's go to the next one. Use a number line to add 3 plus -4. So I'm going to have a little bit bigger on this one. -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. All right. So we've got +3. So from 0 to 3, there is 3. Remember, if it's positive, you're going to the right. All right. Plus, now we've got a -4. So with the -4, we have to go to the left. So from the 3, now we're going to go backwards 4 to right here. And that's -4. We end up at -1. So 3 plus -4 is -1. I want to do the next one, and then we'll talk about this one. All right. Use the number line to add -3 plus 4. Here's my number line. All right, so let's go with -4, -3, -2, -1, 0, 1, 2, 3, 4, and 5. All right, So we're starting off at -3. So from 0 to -3, we're going to the left because it's negative. We're going to go to the left to -3, and then it's +4. So from the -3, because it's positive, we go to the right 4. So there's 3 plus 1 more is going to end up right here, and that's +4. So -3 plus 4 is +1. All right, here's my tips for this, and I'm going to add more down here, but just to show you with the 2 that we just did, and I'll define it again here in a minute, just to make sure you have it again in a different version. This is straight from me without any other thoughts on it, is when the signs are different. When you have the signs are different, we've got +3 and -4, -3 and +4. When the signs are opposite or are different, you're going to subtract the 2 numbers or take the difference. Are different. You're going to subtract, and then you're going to take this, or the answer. The answer gets the sign of the larger number. Okay, so here, the signs are different. We subtract it. When you subtract, you're going to get 1. 4 minus 3 is 1. It doesn't matter. Okay, but then who's larger? 4 is larger than 3, and 4 is negative. So therefore, the 1 has to be negative. For the next one, the signs are different. We subtract. 4 minus 3 is 1. Who has the larger number? It's 4. 4 is larger than 3, and 4 is positive, so 1 is positive. That's how I learned it. Let me give you another way to think about it. So note that the use of the parentheses in these expressions is only to get your attention to understand that you're still, the integer is negative. It's just to help you understand that the parentheses are not representing multiplication in this case, because there's a letter, or I'm sorry, there's an action, a plus sign in between the parenthesis and the other number. So if it was 3 times 4, that's different. That's not what we have. This is multiplication. This is an addition sign. Same thing for here. It would be -3 times 4. That's not what we have for any of these. So it's just to help you understand that there's a negative sign in there. When writing an expression containing a negative number, it's clearer to put parentheses around the negative integer. All right, and you'll see me use that a little bit as well. So if the numbers that you're dealing with, and they're coming back up here to my original, and if they're both positive or they're both negative, that's the part we're going to write down here. To add 2 numbers with the same sign, whether they're both positive or they're both negative, then one, you're going to add the absolute values. So you're going to add the absolute values of the numbers and ignore the signs. Okay. The absolute value of the number is just taking the number without the sign. That's the way we want you to think of this. Okay. So even though it's -3 and -4, we want you to see it as just 3 and 4. So that's what they're referring to when they say the absolute value. Remember, the absolute value of -3 is 3. Absolute value of -4 is 4. So they're wanting you to think of 3 plus 4. All right. Then for the part 2 on these, they want you to answer. The answer has the common sign. Answer has the common sign. I had said the answer has the same sign as the other 2 numbers that are being combined. All right, same concept. So let's go to adding 2 numbers with different signs. All right, just to give you a different way of writing it. That means that one of the signs is positive, one positive, and one is negative. When you have that circumstance, first thing you're going to do is subtract the absolute values. and ignore the signs. Okay, then the answer, this is the important part, well, they're all so important. The answer has the same sign as the number with the larger absolute value. The answer has the same sign as the number with the larger absolute value. Okay. All right. Now, here's an example of some different things we're going to deal with. Looks like these, oh, no, we got different things for these. So these two have the same sign. They're both negative. So in the first one, it says when they have the same signs, we add the numbers. So 5 plus 9, I'm going to rewrite it, -5 plus -9. 5 plus 9 is 14. Okay. But then we take the sign that they have in common. So the answer is -14. Okay. The next one, the signs are different. So we're going to do exactly as it says up here. The signs are different. One's negative and one's positive. We're going to subtract them. So I'm just going to ignore the negative sign. 9 minus 3 is 6. And then I'm going to answer is going to have the same sign as the number with the larger absolute value, which would be 9. And it is negative. So therefore the 6 must be negative. Okay. The next two, 6 and -4, have different signs. We're going to do the same thing we just did with the last one. We're going to ignore the negative, and we're going to go just 6 minus 4 is 2. Now, the next piece of it is look at the 6 and the 4. Who's larger? 6 is larger than 4. So we take the sign of the 6, which is positive, and our answer is just 2. You do not put +2. Just keeps it cleaner if you don't, but it is +2. When using your calculator to find sums with negative numbers, be aware of what button you're using for the negative sign. Oh my gosh, this will mess you up if you're not careful. Your calculator should have a negative key, which could look like either this, which would be on the bottom right of your calculator typically, or you'll see this. So this one is on my graphing calculator, and it's right here. Your positive and negative one that it showed first should be down in this general area of your calculator as well. It is different from your subtraction key. You cannot use your subtraction key to create negative numbers. It's not going to behave the same way. Your answers will be wrong. If they're not, you're going to be very lucky in that. Okay, please be careful. If you can't find it, if you could send me an email with your model of your calculator, and or you can even look it up. Where is the negative symbol on, and then type in the model of your calculator. All right. The law for addition or of whole numbers still applies when working with the integers. Okay, so let's talk about commutative law of addition, and that's just a plus b is equal to b plus a. All right, and to show how that works, it would be, let's just say that a is -3 and b is +4. So that would be -3 plus 4 is equal to 4 plus -3. And to prove that, the signs are different, so we would have to subtract them, get a 1, and then we take the sign of the larger number, which is positive. Okay, so it's already positive. Same thing over here. Signs are different. We subtract them, take the sign of the larger number. They're equal. So the commutative law of addition works for integers. Okay, until you can find something that doesn't work. Associative law of addition, and that's just a plus b plus c is equal to a plus b plus c. An example would be 1 plus -2 plus 3 is equal to 1 plus -2 plus 3. All right. 1 plus -2, signs are different, subtract. We take a 1, and we take the sign of the larger number, which is negative. Now our parentheses is gone for that part. Plus 3 is equal to, oh, bear with me one moment, please. So sorry about that. Good friend of mine's having surgery. I just want to stay on top of it. All right, so let's keep going. I'm going to finish the left side of this equation. Just makes more sense to me. So the signs are different. We have to subtract them and then take the sign of the larger number, which is this one. All right, which is already positive. Now let's go to the right side. 1 plus, and then we've got -2 and +3. We have to subtract them. Take the sign of the larger number. Okay. And now 1 plus 1, which is 2, they're equal. So, yep, associative law works in addition for integers. Additive identity property. Okay, so that's just a plus 0 is equal to a, which means we can take any integer, let's just say -5 plus 0, and we should get -5, and we do. Okay. Additive inverse property, and that's just a plus -a is equal to 0. Well, let's go with 4s this time. If I say that 4 plus -4, well, that's equal to 0. The signs are different. We subtract them. We get 0. We don't need to worry about a sign for 0 because it's neither positive or negative. So we're done for that, and that proves it as well. All right. When we are adding many numbers together, it can be helpful to group for efficiency. Efficient means faster, easier, correct, faster, easier, correct. In general, our goal is efficiency. The terms I like to use is work smarter, not harder. Use the commutative property. In using the commutative property, we can arrange the add-ins, the numbers themselves, so that the positives are grouped together and the negatives are grouped together. If that, and then that'll probably make it a lot easier for you as well. So cool, this is gonna be fun. All right, so here's what they're referring to. Instead of going, so that kind of bothers me because you're more apt to make mistakes if you do something like that. Okay, if you group them, and I'm going to do it just to show you what they're referring to, but it doesn't make me happy because I find that people can make more mistakes when they start moving stuff around, dropping signs. That's the biggest issue that I see. I'm going to go with what they're asking me to do here, but then I want to show you the way I would tackle this just to ensure that I'm covering my order of operations, PEMDAS, and staying true to that. Sorry, I've been working with too many animals. All right, so -11, we've got a negative here, we've got a +3, we've got a -2, and we have a +7. So what they're wanting us to do is put the ones that have like signs together. So -11 and then plus -2. And they're wanting us to just separate those off from our 3 plus 7. I'm going to do it. -11 plus -2. When the signs are the same, we add them together and keep the sign. 13, and it's a negative. All right. Plus 3 plus 7 is 10. Now, we've got a negative and a positive. We subtract the two numbers, 13 minus 10, we get 3. And then we take the sign of the larger number, which is 13, and it is negative. There's your answer. If you like that way and you're comfortable with it, use it. I'm going to go a different route. -11 plus 3 plus -2 plus 7. If you're going to plug this in your calculator, which you're all going to do, start with the -11 plus 3. Do not put the +2. In your calculator itself, you're going to go -11 plus 3 minus 2 plus 7. Okay? Straight like that into your calculator, and you're going to get -3. When though I do it, however, if I'm doing this without my calculator, which is what I do for fun, don't ask. -2 plus 7, -11 plus 3. Signs are different. Subtract, keep the sign of the larger number. So that's 9. That would be an 8. And then I'm going to bring everything else down. These two, the signs are the same. Add them, keep the sign. These two, the signs are different. Subtract them, keep the sign of the larger number. That's it. Those are the different ways you can do it. All right, recall subtraction is the opposite or inverse of addition. Okay. Subtraction means add the opposite. Okay. So that is if A and B are any integers, then A minus B is A plus negative B. All right. So if you have 7 minus 4, that's the same thing as 7 plus negative 4, which is signs are different. You're going to see me putting it like this. Signs are different. Subtract them. Take the sign of the larger number. So you're going to go subtract them. The 7's positive, so the 3 stays positive. These two can be written as 4 plus negative 7 if it helps you to see it a little bit better. The signs are opposite. You're going to subtract them and take the sign of the larger number. So it's negative 3. Negative 7. So I'm going to go negative 7 plus negative 4. The signs are the same. So when the signs are the same, you add them and they share the same sign as the answer. The answer shares the same sign as the two add-ins. And then the last one here is negative 4. And then we've got, wow, minus. Well, if we have a negative here and we want to make it the opposite, how are we going to make that happen? Well, a negative and a negative is already going to be a positive, and that's just going to make it a 7. Signs are different. We're going to have to subtract, pardon me, and take the sign of the larger number, which is 7. All right. Find the differences. So for A, we've got 4 minus 8. Signs are different. I can write it just like this, or I can write 4 plus negative 8. Signs are different, so we're going to have to subtract, take the sign of the larger number, which is 8. Negative 15 minus 13, so plus negative 13. The signs are the same, so we add them and keep the sign. All right. For C, negative 117. Oh, negative and a negative is a positive 115. Signs are opposite, so we need to subtract and take the sign of the larger number. All right. Let me know what questions you have on that. I never like putting them in parentheses, but I'm starting to like putting them in parentheses, I have to say. When we encounter an expression containing both addition and subtraction of integers, we follow the order of operations, which says to evaluate addition and subtraction from left to right, which is what I did when I did mine up here. That's exactly what I was doing with following the order of operations from left to right. So I did my subtracting, keep the sign, and then I had to add, keep the sign, and then I had to subtract and keep the sign. You had to just keep going from left to right. When we encounter a subtraction, we change it to addition of the opposite. That's what we've been doing this whole time for these, of the opposite. All right, note that when we change to the opposite, we only change the one number that comes directly after the subtraction sign. So let's simplify this. Left to right, we need to deal with some things like this guy right here. All right, so we've got negative, I'm just going to rewrite this as negative 3. A negative times a negative is a positive 9 minus 11. When you have a negative right next to itself, it's going to have to turn to a positive like that. Now we've got the first two. The signs are different, so we have to subtract them and then take the sign of the larger number. Negative, so 9 minus 3 is 6, and then the 9 is positive, so the 6 stays positive. Plus negative 11, just going to bring that down, and the signs are opposite, so we have to subtract and take the sign of the larger number. Okay. 2 minus 7 plus negative 8. So the way I can think of this is 2 plus negative 7 plus negative 8. So 2 plus negative 7 is the first thing I'm going to deal with, left to right. Signs are different. They're opposites, so we have to subtract. 7 minus 2 is 5. Sign of the larger number would be a negative. Plus negative 8. signs are the same, so we have to add them. So 13, and we take the sign of the two addends. All right. Ooh, this one's different. So this one is we're going to have to do a distribution. So I'm going to rewrite this, but I want you to understand something. We need to do what's inside the parentheses first, because remember, order of operations is parentheses. So we have to do what's inside these parentheses first. So I'm going to go -3 minus, all right, the signs are the same. I could rewrite this though to -4 plus -5 inside that parenthesis. The signs are the same, so we add them and keep the sign. 4 plus 5 is 9, and they're both negative, so there you go. I'm just going to bring everything else down. Now we have a negative and negative right next to each other. When you have it like this, it becomes a positive. Because this just means a -1 times a negative. So a negative times a negative is going to give you a positive. Now we have opposite signs. We have to subtract them, which gives us a 6. And we take the sign of the larger number, which is 9. And that's my final answer for that one. All right, last page for lesson 8 is suppose that when I leave my house in the morning, the temperature outside is 40 degrees Fahrenheit. Later in the day, the temperature measures 60 degrees Fahrenheit. How do I measure the change in temperature? So when you're wanting to measure a change in something, you're wanting to subtract. You're wanting to know the difference. So you're going to have to subtract the two numbers. So 60 minus 40 is 20. So how do you measure the change in temperature? You subtract. So later in the day, so it's a 20-degree difference, 20-degree change in temperature. All right. To measure the change in quantity, always subtract the earlier measurement from the later measurement, from the later measurement. I have another way I say this, and it will carry through to my 1500 class if you take me, and that's just new minus old. But in this case, that's to measure the absolute change. They're doing it differently. No, they're not, but they're saying it different. So I'm going to say it this way: the new temperature minus the old. So the new temperature is 60 degrees, because that's what it is later in the day, right? So that's our new temperature, 60, minus the old temperature, which was 40. That's the way I like to use it, and that's what I'll use whenever we're talking about changes in problem solving. Note that a positive change indicates that a quantity has increased, okay, while a negative change indicates that the quantity has decreased. And those are the words that we're going to use both in this class as well as when you come into problem solving. All right, so if it's a positive change, that means the value is increasing. If it's a negative change, that means the quantity is decreasing. Suppose that in the afternoon, the temperature measures 65 degrees Fahrenheit. Then later in the evening, the temperature drops to 44 degrees Fahrenheit. Okay, but we're doing new minus old. So the new temperature is 44 degrees. I'm going to write this: new minus old. The new temperature is 44 degrees, and the old temperature is 65 degrees. So I can write this as 44 plus -65, which is, the signs are different, so we have to subtract. And so that's going to be 21. And then we take the sign of the larger number, which is 65. And so it's a -21. It says find the change in temperature. The temperature. So we're going to use either increased or decreased. The temperature decreased by 21 degrees. Please notice that I didn't say -21. we have to use the word decrease to represent the negative. You will not say it decreased by -21. That's no bueno. Please do not do that. That's very incorrect. Okay. So the temperature decreased by 21 degrees. Give ourselves a complete sentence. We've got correct units with our degrees, and there's no rounding required. All right. Sometimes the bar graph is not the most appropriate visualization for your data. The bar graph shown below displays the Dow Industrial Average for 7 consecutive days in March of 2009. Why is it difficult to use this graph to see the change from day to day? To me, they all look pretty darn close to the same. That would be my answer. The values are too close together to notice a change. The values are too close together. Okay, so instead, let's construct a line graph of the change in the Dow Industrial Average on a day-to-day basis. All right, so let's go with days and change. We're going to have to calculate the change on these. Okay, so we're going to have Sunday to Monday, Monday to Tuesday, Tuesday to Wednesday, Wednesday to Thursday, Thursday to Friday, Friday to Saturday. Okay, I think that's all we have. Friday to Saturday. Yep, because then it starts a new week. All right, so the change is new minus old. Okay, the new value would be Mondays, and the old value would be Sundays. So that's going to be 6,900 minus 7,000. I'm going to put my calculations here, and then my totals, my actual changes here. So that's separate. Okay, the different signs. So we have to subtract and take the sign of the larger number. Okay. Tuesday is 6,800 minus Mondays, which is 6,900. Same thing, subtract, take the sign of the larger number. All right. What happens from Tuesday to Wednesday? There's the exact, I know this is hard to see, it's a little blurry. There we go, get a little closer. No, it's not going to clean up anymore. But they're both 6,800, so there's no change. 6,800 minus 6,800, there's no change. Wednesday to Thursday. Wednesday is 6,800. Thursday is 7,000. So there's a difference. New minus old. Subtract them because the signs are different. Take the sign of the larger number, which is the 7,000. All right. Thursday to Friday. The new value is 7,100. The old value is 7,000. Subtract the numbers because their signs are different, and take the sign of the larger number. Now we've got Friday and Saturday. Saturday is 7,200. That's the new minus the old, which is 7,100. Subtract them because the signs are different, and then we take the sign of the larger number, which is the 7,200. All right, let's create a line chart to, a line graph to create what's happening here. So I need, there we go. I'm going to create my days, because remember, time goes along the horizontal axis. So create Sunday, Monday, Monday to Tuesday, Tuesday to Wednesday, Wednesday to Thursday, Thursday to Friday, and then Friday to Saturday. All right. Okay, and then I need some changing. I've got negative 100s, zeros, and then I go up to 200. So I need to represent at least in hundreds, but I can break it down even further if I wanted to. I could do like 50s or something like that. No, I don't need to though. There's no reason for that. So I'm going to create my horizontal line. This is going to be my 0. And then I'm going to go up by 100, 200, 300, 200, 100, and then negative 100, negative 200. All right. Sunday to Monday, it was at negative 100. Monday to Tuesday was the same. Tuesday to Wednesday was at 0. Wednesday to Thursday was at 200, so that's right about there. And then Thursday to Friday was 100. And same thing for Friday to Saturday. Now we just connect our dots. All right, need to reference that this is my change over here. So I do need to give a label to that. I've got my labels. I've got representation of what each is. I've got my time on my horizontal axis. I've connected my dots. Looks good. All right, if y'all have any questions on lesson 8, let me know. Otherwise, y'all have a great day and I'll see you next time.